A non-conducting ring of mass m and radius r is charged as shown in figure, placed on a rough horizontal surface, non-conducting plane. Rough non-conducting plane. The charge per unit length on the quadrant of the ring is lambda. The charge is like this: 90 degree here, 90 degree here. The time t equal to 0, a uniform field E is equals to E naught I is switched on and the ring begins pure rolling. Determine the magnitude and direction of force of friction acting on the ring when it starts rolling. See, when pure rolling begins, the kinetic friction doesn't act. What acts is the static friction. That never becomes zero. So, if I have the electric field in the positive I cap direction, it will have force in the positive charge in this direction and the negative charge in the backward direction. So the ring will rotate in the clockwise sense. And the ring is rotating in the clockwise sense, then tendency of this point will be to go here. And hence the friction force will be acting in the forward direction. Now we know that torque is equals to, that is I alpha, which and alpha is equals to torque upon I, and alpha at this point, for this point we can write A divided by R. That is the acceleration. So torque I you can write like this, and then A is equals to R tau by I. So I reached up to acceleration of this point. Okay, and this can be replaced by friction upon mass. So from here we can find out the friction force, which is mr tau divided by I. Now the torque is due to two forces, due to two reasons. One is the electrostatic field is rotating the ring, and another force is having a torque on the ring is the friction itself. So the torque net I should be writing torque net. Okay, so this torque net is actually torque due to electric field force and torque due to friction force. The friction force is simple, that is simply F into R. Okay, center, this is F and this is R distance, so I'll simply write electric field minus FR. So main concern is to find out the torque acting on this ring due to the electric field. For that we'll start solving. Let's see. So we have charges only up to this point and here also. So what we'll do is we'll take a small portion, okay, a very small portion, say from angle theta, and apply a force here, df, which df can be written as dq into E naught, and dq can later be written as lambda. If I take this portion as x, lambda dx into E naught. Now this can be easily written as rd theta. Lambda dx is rd theta. You can easily write like this. See, this is the angle d theta, small angle, which is subtended by a small element dx. Okay, so we know that angle equals to arc upon radius. Okay, radius is r, so I've written rd theta. That's the reason I've written angle equals to arc upon radius. Arc is dx na, so rd theta I've written here, and E naught continues. So we got this df force. Similarly, this is a negative sign, so I'll get a df force in the backward direction. Okay, and this will constitute me a torque. That is the distance between these two forces, equal and opposite forces, multiplied by the force, either force. That is a formula for torque. Now this is r, this will be r cos theta, and this will also be r cos theta. Okay, because they are symmetrical, isn't it? So I have torque as force, which is lambda r d theta into E naught into distance between these two forces, that is 2 capital R. This is theta cos theta cos theta. So we got the torque as 2 lambda r square, 2 lambda r square E naught integration of cos theta d theta from 0 to pi by 2. That is what is written, no? from 0 to pi by 2 because it is only in the first quadrant charge. So we have 2 lambda r square E naught cos theta is sin theta 0 से pi by 2. This will become 1. So we got the torque as 2 lambda r square eta E naught. That is the torque we have got. And we just now found this expression, this F is equals to mr torque. F is equals to mr torque net divided by, I think, I. Now let's keep all the values. M is M, R is R. It's a ring, so answer will be mr square, and torque net would be 2 lambda r square E naught minus FR. That is what we did. Now you can take R outside, so we'll get mr square upon mr square. So we get 2 lambda r E naught minus F. So this gets cancelled. So I'll get 2F is equals to 2 lambda r E naught and F is equals to lambda r E naught. That is the answer to the question. Friction acting on the ring.